Okay, so this is a project that you can do for risk management. You can see after tonight's discussion if you really want to do this. I've never done it with fake numbers. I've only done it with real numbers. But I'm going to say how I would do it if I were doing it. You may do it a different way. But what you need to do is the very first thing you need to do is you need to create a fictitious scenario. You can do a bank, or I think even better would be to do a pension plan. I know in class we didn't talk about a pension plan, but as I think about it, the pension plan may even be better. So why do you need to create a fictitious company? Well, you gotta describe their liabilities in terms of duration and convexity, and you need to describe their asset allocation, stocks, bonds, and then the duration and convexity of the bonds. So you have to make a fictitious company with these type of characteristics. All right, so I'm gonna do a pension plan just because I think that's the easier way to go about this. If you do a bank, you might, you're gonna have to just come up with some way of knowing what the duration. If you do a bank, you don't have to necessarily do convexity, because convexity is not a huge issue with banks. But if you do a pension plan, you'll definitely need to do that. All right, so let me show you how I did it. So I took the file I gave you. It's out there on Blackboard. It's that duration convexity file. I don't know if y'all remember that. What I did is I did it a little bit differently. If you remember good old Robert Arnott and his article, I essentially took his article and I created a pension plan that looks a lot like the pension plan he has in his article. Y'all remember that chart? Very few of us could really understand exactly what he's after. So hopefully the systems here works pretty well. So if you go to Blackboard for our class, I'll try not to badmouth UTSA system since I'm recording this. It's ridiculous how slow this is. So as you at home it'll be a whole lot faster than it will be here, so it won't take quite so long. But you'll bring the file up, and then the duration convexity file is under class files under files related to interest rate risk. I'm going to try retyping the password. Alright, so bad password, sorry. Alright, so you come to the risk management class. And so the file I'm using is this one called Class Materials, Interest Rate Risk, and it's that very first one, the Duration Convexity file. But this file is set up for non-amortizing debt. So you can see the only cash flow is the coupon. So what I did is I took that file and then I took the article written by Robert Arnott under our papers and projects, the Arnott article. And if you remember this chart right here, these blue lines, that's the percentage of the forecast cash flow in the pension plan that he's expecting over the next 50 years. You see it starts off, and this adds up to 100%. You can see, right, 1.5%, gets up to like 2.7% and comes all the way down to 0.7%. So over the next several years, that's the cash flow they're expecting. As more people retire, and then eventually as people start dying. So what I did is I took that and I tried to replicate it. I just guessed as best as I could. Y'all can see I don't get real close, but I kind of ballpark that cash flow. Y'all can see that, so I just made it up. I'll share this with you so you don't have to recreate it if you don't want to, but I got it to add up to 100% and had it look like it's evenly distributed. And then I said, okay, let's say this pension plan is going to pay out $3 billion over the next 50 years. 1.63% they're going to pay out next year, then 1.69, 1.75, so I'll try to replicate that. So here's just the cash flows from the pension plan over the next 50 years. And so this spreadsheet works perfectly fine if you put those cash flows in it. It will calculate the duration and convexity of your pension plan. You have it right there, all right? So if you wanted to, you could create a plan that has more duration or less duration or more. You know, this is what we call the APO. This is just the pension plan for things people already accrued. The PBO would be if they accrued, if the plan was still open, they were still accruing more benefits, then it would just keep growing and growing and growing. So the APO is the best way to do it, and that's what Robert Arnott is using. So y'all see how I did this. I had to have some forecast on my pension plan. So I just used Robert Arnott's article to give me something. You can create your own distribution if you want to, but you need something that's pretty well distributed over 50 years. At USA, we went out 75 years.
Is there a way to do the distribution without going number by number and then making sure it adds up to like some function?
I had the starting point, and then I had it. I could tell that his slope was getting narrower, so it probably took me a good 20 minutes to get this to work. So you have to sit down and kind of work with it. But there is a function in that it's spreading it out. I knew that it got to about 2.7 and 2.8, and then it's hung there for a few times, and then it started coming back down. So I had it rise fast at first, and then slow down, and then even and come back down. So I just made something else, and you can tell it's really way off of his. It's much more linear. His has kind of curvature to it, but that's me. How many pension plans are there? There's probably all different types of distributions. So you need to make something up, but you need to add it to 100%. So that you can get your cash flows. Once you have the cash flows, remember for duration and convexity, all we need is those cash flows. Once you have the cash flows and a discount rate, you can calculate duration and convexity. And you don't have to know the formulas because it's already built in there for you. That convexity formula is like pain, but it's already built there. You don't have to do any extra. And I'll show you that it actually works. It works pretty well. In fact, I'll show you right now that it works pretty well. So let's say your discount rate is 5%, and there's your liability. You expect to pay out $3 billion over the next 50 years, but in today's dollars, your liability is 1,183. So what would happen if interest rates were to fall 2%? So you use this formula right here. You remember this formula? Minus duration times the change in yield plus convexity times the change in yield squared divided by 2. If I do that, if interest rates were to fall 2%, so minus duration times the change in yield plus convexity times the change in yield squared divided by 2, I would expect this liability to go up 37%. So if I take 1183.73 plus 445.7514, I would expect this liability to go from 1183.73 to 1629. So let me try. Interest rates fall 200 basis points. It's pretty close. And it's not going to be exact because duration and convexity actually change as interest rates change. So it's only a point X, but that's pretty close. If you tell your boss, I think it's going to go to 1629 and actually goes to 1645, that's going to be a pretty good estimate. All right. So I need this spreadsheet because you're going to see what we're going to go back and do when you do your analysis, which is going to be really, really key. You're going to need a spreadsheet like this. And you're going to have to manipulate it something. So y'all see that the first thing you got to do is you got to project your liability. The best way to do it on a pension plan is like this. I think this is a whole lot easier to understand in the bank. With the bank, you're just making numbers up. Kind of what we did in the exercise. It's not quite as exciting. Where here you can use Robert Arnott and build that. So you need to describe it. So the liability for a pension plan, if you just forecast the cash flows and then use the duration and convexity calculator, you've got pretty much what you need. What about the asset allocation? Well, what I would think you might want to do is you might try 3 scenarios. You might try a typical pension plan, which is 70% stocks and 30%, say, short-term bonds. That's the scenario that Robert Arnott talks about that's so bad, right? You might try 25% stocks and 75% long-term bonds. And then you might try 25% stocks, 75% long-term bonds, and an interest rate swap. You might try those 3 scenarios, and what you can do is say, hey, which one really controls my risk and my return the best? Now, you come with your own scenarios, however you want to do it. You know, maybe do 60-40 or something, whatever you think is a typical pension plan. And I'm just going to show you how you do that. But first thing you need to define your company. So you can use the spreadsheet I already have built for you. It's probably going to take a little bit longer than the other class exercises doing the portfolio efficient frontier, but it's possible. All right, so y'all see how I built this company? I got the duration and convexity. I'm actually not going to use this duration and convexity when I'm actually pricing it. I'm going to actually use the actual numbers, but I'm going to use this spreadsheet to price it. But this is going to help me get my dollar duration gap analysis. All right, so y'all remember how to do that? So you might, for example, say, I've got a pension plan that has, well, you have it right here. It has $1.645 billion, or however you started it. It has $1.2 billion in liabilities, and you say it has $1.4 billion in assets. However you want to, you just make your own. What kind of surplus it has. And then once you have that, you know, you have what you have to work with, and then you say, you remember the dollar duration gap analysis. What's the duration of your assets? What's the duration of your liabilities? You've got the duration of your liabilities here. The duration of your assets, if I were you, I would ignore the duration of stocks because I don't think it works. So the duration of your assets is going to be really, really short because you only have 30% in bonds and they're short term. And so when you figure out the duration of your assets, it's going to be really, really short. So if you say these bonds have a duration, say, of 2 years or 3 years, you do 3 years times the dollar value of your assets times 30%, and that's going to give you that asset piece. All right. So there's how we start off with your first assumption.
So stocks have no duration, or
I'm going to say 0. We know it's
extremely long.
We know it's, and sometimes it's really, really long duration. Sometimes it's actually negative duration, like in 2008, the worst possible time. It's actually the worst thing you can have. So it really kills you when rates fall. So it just, I say 0 because it's so unreliable. So the only interest rate hedging you're getting is this piece here. Now here, you have a whole lot more. What's your duration of long-term bonds? Again, you can use this spreadsheet. A long-term bond is what? Has a maturity, say, of 15 years. You can look at this and see what your duration is. We're going to ignore convexity for right now. All right. The next thing you need to do is you need to create an interest rate swap.